right, diving in today, and it's a hot topic, literally. We're talking fire,
Oh, yeah, fire. Always important.
but not just, the pretty flames and all that. We're going full on science here. And of course, the big one, how to, not get burned, literally.
Stay safe, yeah.
Stay safe. So you sent over some really in-depth training materials on workplace fire safety.
Mm-hmm.
And I got to say, wow, there's a lot to unpack.
It's a whole world, yeah.
So our mission, should we call it a mission?
Sure, a fire mission.
I like it, a fire mission.
Yeah.
To break down the essentials.
Okay.
What is fire, really? Why is it so dangerous? How does it even start and then keep going?
Mm.
What can we actually do to prevent it in the first place?
Mm.
And then, if it does happen, how do we put it out?
Sounds like a plan.
Let's do it.
Yeah.
So I was struck by how the material started. Talk about the chemistry.
Right.
It's chemical reaction, fire is.
It is, yeah. And it's a fast one. Rapid oxidation, they call it. You need fuel, you need oxygen, and then boom, enough heat, and you get those flames, that light and heat.
And it's funny because they actually compare it to, like, rust.
Yeah, slow oxidation, they call that.
Slow oxidation and then explosions on the other end of the spectrum. Super fast.
Way too fast.
And fire is right in the middle.
Goldilocks zone of oxidation.
Yeah, exactly.
Yeah.
But of course, fire has those extras, right? The flames we can see.
Yeah, and the smoke. Don't forget the smoke.
And the smoke. And, well, the danger really starts there with those byproducts.
Yeah.
It's not just the burns, which obviously that's the first thing you think of.
Sure.
But it goes way beyond that. I mean, there's the obvious property damage.
Oh, yeah, that can be devastating.
But then you've got the risk to, like, everything around the fire.
Mm-hmm. Spreads like crazy if you're not careful.
And then they talked a lot about the environmental impact, which I'll admit I don't always think about with fire.
It's significant, though. Those toxic gases, carbon monoxide being a big one, contributes to global warming, they said.
And all the water used to put out fires, that gets polluted too.
Right. It's a mess.
And the way fire develops, there's like stages to it.
They laid it all out, yep. Starts at that ionization phase, can't even see it.
Like a stealthy beginning.
But thankfully, we've got detectors that can pick it up, give us some warning.
Early warning systems are key.
Absolutely. Then the heat kicks in pretty quickly, too. Our bodies know something's up right away with that.
Yeah, you can feel it. And that leads to, of course, the flames. When everyone pictures when they think of fire, they spread like crazy, grab onto anything they can.
Right, especially if there's a lot of fuel around.
And if the combustion, that burning process, isn't complete, that's when you get the smoke.
Yeah, that mix of particles and gases all swirling around. Can't see through it, hard to breathe.
And they made it very clear it's often the gases, especially carbon monoxide, that are the biggest danger.
Oh yeah, that's the silent killer.
Silent and deadly.
They really drilled it in. It attaches to your red blood cells way faster than oxygen can.
Hugs all the space, basically.
Pretty much. And then your body's starved for oxygen. You get disoriented, pass out, and, well, you need oxygen fast in that situation.
Absolutely critical. So then the next question, of course, is, well, how do these fires even start? And honestly, the materials listed so many things.
Right. It's like a whole laundry list of potential causes.
Human error was a big one, which, I mean, we've all been there.
Mistakes happen.
But then you've got the electrical faults, industrial accidents, things we might not think about as often.
Right. Equipment failures. Those can be nasty.
And nature throws its own curveballs, too. Lightning strikes.
Oh, yeah, that'll do it.
Extreme heat.
Things can get pretty dry, really flammable.
And then even poor ventilation can create a dangerous situation.
Mm-hmm. Lets those flammable vapors build up, ready to ignite. Not good.
Not good at all. And then they talked about the classic fire triangle. I remember learning that in school.
Oh, yeah. Fuel, oxygen, heat.
But they actually call it a tetrahedron.
Right, because you've got to add in that chain chemical reaction.
That's how the fire sustains itself, right? Keeps going.
Exactly. Fuel, well, that can be anything, really. Gases, liquids, solids.
If it burns, it's fuel.
Basically. Oxygen, that's usually just from the air around us. And then heat, well, there's so many sources. Faulty wiring, hot surfaces, sparks, anything that can get things hot enough.
I was actually surprised by some of the things they mentioned as potential ignition sources.
Yeah, what gotcha?
Static electricity, that was one. Like friction can cause a spark.
Oh, yeah, I remember that from science class, rubbing a balloon on your hair.
And spontaneous combustion, that was another one. Like certain materials, they can just heat up on their own.
Right. Some chemical reactions can release heat, like
Yeah.
oil-soaked rags. They can be a fire hazard.
It's crazy to think about. So we know how they start. Now the big question, how do we stop them? The basics, of course, removing fuel, cutting off oxygen, cooling things down, and then stopping that chain reaction we talked about.
Those are the key strategies. And water, good old-fashioned water, is amazing for cooling.
Yeah, but there's some fires you don't want to use water on.
Right, like electrical fires, definitely not a good idea. And some metals, water can actually make them worse.
So that's where the different types of fire extinguishers come in.
Exactly. They talked a lot about foams, different kinds, and how they work.
It's pretty interesting, the science behind it.
They blanket the fire, cut off oxygen, cool things down, even break up the fuel sometimes.
Then you've got dry chemicals, those mess with that chain reaction, stop it in its tracks. And dry powder, that's specifically for those really reactive metal fires.
Right, class D fires, they call them. Magnesium, sodium, potassium, those kinds of metals.
Dangerous stuff.
And carbon dioxide, CO2, that's a good one for electrical fires because it doesn't leave any residue, but it doesn't work so well on regular combustibles.
So the right extinguisher for the right job.
Absolutely.
And speaking of extinguishers, the materials covered, portable ones, fire blankets, all that. And they really stress the importance of having them in the right places.
Makes sense. You need to be able to get to them quickly.
Easy to access, clearly visible, and the right type for the potential fire in that area.
No point in having a water extinguisher next to a big vat of flammable liquid.
Exactly. And regular checks, they can't just sit there and gather dust.
Nope. Got to make sure they're in working order.
Pressure's good, no damage, all that.
They said to check them monthly, at least visually.
And then, of course, knowing the basics of how to actually use a fire extinguisher.
Aim at the base of the fire, sweep back and forth, that kind of thing.
And they were very clear, if you're not trained, don't try to be a hero.
Right. Safety first.
Get out, call the professionals.
And always have an escape route. Know how to get out safely.
Absolutely. So we've talked about putting out fires, but preventing them in the first place, that's the real goal.
They called it fire prevention, a whole section on it.
Risk assessment, that's a big part of it. Figure out what the hazards are, where the risks are.
Right. Identify those ignition sources like we talked about. Hot work, electrical equipment, all that.
And then, of course, safe storage of flammable materials. Good housekeeping, they called it. Keep things clean and organized.
Clutter can be a fire hazard, definitely.
And they had a really interesting section on how fire affects different materials.
Oh yeah, like steel and concrete.
They actually change their properties under high heat,
Steel expands, concrete can crack or even crumble.
which can lead to structural collapse. So it's not just the fire itself, it's the aftermath too.
Right. It weakens the whole building.
And early detection, that's key.
Right.
Alarm systems, smoke detectors, all that.
Absolutely. The faster you know about a fire, the better your chances of getting out safely.
So I think we've covered a lot of ground here. It's clear fire is a serious business. It's a chemical reaction with the potential for a lot of damage and danger.
No doubt about it.
Knowing how it starts, how it develops, and how to stop it, that's crucial.
And prevention. Can't forget about prevention.
Being aware of the risks, taking steps to minimize them, and having the right safety measures in place, that can make all the difference.
It's all about being prepared.
Exactly. And that actually brings us to a question for you, the listener. Thinking about everything we've talked about, what's one thing you can do today, right now, to improve fire safety in your own life? Maybe at home, maybe at work. It could be as simple as checking the batteries in your smoke detectors or reviewing your evacuation plan with your family. Whatever it is, take action, be proactive, and stay safe.
That's the best advice.
All right, that's our deep dive into fire safety. Thanks for listening.
Stay safe out there.